evening, and being I would say conflicting topic, people have different thoughts in their mind. I bet I'll try to convince you better so that you take home this lesson and try to implement in your company or whatsoever it is. All right. So I'm Sainath Ramanathan. I'm coming from Chennai. So I work for Zenza Technologies, an interesting company. We do it's a consulting and a service-based company. We do a lot of tech-based implementation. We do digital engineering and so on. We have got 145 plus global clients and 10K plus employees and so on. A lot of things that we do was experience services, customer experience management, and advanced engineering services like cloud native, full stack, generative AI, legacy migration, transformations, and so on. And we do work in data engineering, application services, and whatnot, cloud, infra, and so on. So I'll be out there. If you have any questions, you can reach me out. We can discuss more about the company and what we do. Okay. Without further ado, I'll jump into the topic. The monolithic front end. Okay. I know that people are a bit, they have sharpened the sword to fight about this. Amazon has gone monolith. Why are you talking about micro front end? After all, microservices getting underrated now. It's not the case. So take it with a pinch of salt. We will discuss about a lot of things, what micro front end will bring you, and what is it trying to solve, and how it will help you. We know that our development team is getting wider and wider. A lot of different people are contributing, and for even a small functional thing, a lot of teams are working on, right? So when it starts to scale, it becomes a problem. You would have obviously faced it. Some would have overwritten your thing, and a lot of mess up would happen. And that's one big problem with a monolith. Okay, and of course, once you have a big code base, usually you will have a large, long build time that takes years and years to compile, though. And that is a tight coupling. What I mean in the sense, you have a strong technological coupling. So when you set foot on one thing and you can't really work on the other, because that will affect this. So there is a sort of friction over there, and there is a technology lock-in as well. And we are advocates to technology, and your leader might be he's fascinated with one tech and doesn't want you to move to other tech because that he likes it. Probably that might be the case. And it will be a case where you can deploy all. Either you have to deploy all the components, whichever is needed to be overhauled. You'll have to deploy or do nothing. You can't do in interim things, or you can't do micro things, right? So these are much of a problem for monolithic frontend. So what are we trying to do? So micro frontend, heard of microservices, right? You would have heard about microservices. Typically, that's what the backend architecture is all about these days. Micro frontends are of similar pattern, where you can distribute your front end into nitty-gritty parts based on functions. We'll see how the design pattern will be. You can split up your whole front end into different buckets, and therein it will help you to develop independently. So you'll have team autonomy. Your individual functional team can own it and do it. It's not that a functional team is separate and they delegate it to a separate UI domain that does all things. That not be the case. It can own its own autonomous things. It's technology agnostic. So we have been seeing a lot of tech stacks recently, right? So started from Svelte. Josh talked about cross browsers and multi-platform and so on. This is where you can experiment different set of technology. Say if I have a specific interest for Svelte, I just told Lead how that I've been using Svelte for VS Code extension. We did the user interface with Svelte, by the way. Thanks for that. Brilliant documentation, of course, Svelte. So if you want to try a specific piece with a different tech stack, you can really do it with a micro front end, deploy it, boom, it's right away in your front end, right? You don't need to wait for anything to happen. And you have isolated code bases and runtime integrations, of course. Okay, so what made this fascinating? Okay, so I'm always curious and interested about how Elon Musk, of course you know him, right, does all these things, right? SpaceX, X, a lot of X. Okay, and it's because the fundamental principles, right? He is very strong with that, and he goes to the fundamental principles. So what made rise to monolithic, micro frontends? It's all the fundamental principles. So we started from, you obviously know that we go with VDD, TDD, Does it ring a bell? Okay. So that is how we started to develop the domain-oriented part of it, right? We went with domain aspect design. So and then distributed computing came, wherein we started distributing even DBs have distributed computing these days. We have distributed NoSQL databases and so on. So all this come into play and give us advantage. Why not try with the front end? We have domain-driven design, which can be done with the front end. And we have a distributed computing. We can have its own computation. And cloud is offering us, the lambdas are there and whatnot. And we have the CDN folks here, right? They're enabling, Cloudflare is doing a pretty good thing. So it all paves way, obviously, for you to do a micro front end. Okay. So what should be the key consideration over here? So I mean, just putting things to perspective, there are different criteria you can just, it's not a one shoe fit all scenario. You can go through your scenarios like, will it really suit you? I'm not going to convince you that go take this and implement this right away. Okay. So first is public facing apps. So you have, say for example, you have a time to interactive that will cost you a lot in terms of public facing apps. And you have a first contentful paint. These are some jargons in the UI, but you can look about it. The basic idea is what is important for you. So if it's a public facing app, its time to interaction is important. First contentful paint is important. Cross browser compatibility is important. If it's an interactive app, right, then optimizing an in-app solution. Optimization plays a key role. And if it's an enterprise app, you should bound with client constraints. Like whatever constraint they have, you'll have to bound with it. So the decision factor should be based on trade-offs, the business context and the usage pattern. This is how you get to decide how your MFE should be. Okay. So I'll dive into some of the core fundamentals. One is how to identify the micro frontend, how do you design this micro frontend, and how do you compose the pages, how do you do the routing, communication, and of course, whatnot, everything that comes along with a typical frontend, right, and how to manage the dependency. So, yeah, I hope it's visible, right, though it's not pretty clear. Let me try to explain you this. So you could see 3 diagrams in here. So the first one is a simple page where you can do a vertical split, meaning you have a catalog which can be a separate domain that can be handled autonomously by a team, and you can vertically split a checkout, you can vertically split an invoice. So that becomes a micro frontend of its own. So there are 3 categories, autonomously handled by a domain, and it's a micro frontend. Then we have a mixed split to your top right. So that is where you have a station finder and a route explorer. So the beauty about this is these two can be its own micro frontend, but what you see is there is a map view which is kind of being used by both. Okay, this is kind of a mixed micro frontend. So you'll have to accommodate your app in such a way that this adapts to all different combinations of the app. And the final one is dashboard type or portal type. There are much more types, but these are the broader types that you could see more obviously. Portal type is something like you will have all the micro frontend, like it's a shell app where you'll have different micro frontends operating on its own. But the criteria is it has to stick with the viewport of it. It has to undergo the authentication authorization process. All this has to go through. So a lot of different constraints has to be, it's more like a handshake that happens between these micro frontends so that they evolve and they allow each other to get it exhibited. All right. So next comes, we are obviously aware of server-side rendering, edge computing, and so on. But let me brief this. So when it comes to MFEs, there are 3 ways you can do it, of course. So with client-side composition, meaning, Next.js sort of frameworks allow both SSR and CSR capabilities. With client-side composition, you assemble the MFEs will be assembled all in the client side, all in the browser, and every tedious operations happens in the browser. It's so in a way this happens in the browser. This is it takes time. The time factor is resolved here, but the browser gets heavy, right? That's the downside of client-side computation. The next one is edge-side computation, meaning we offload things to edge. Edge meaning a CDN. So a Cloudflare or AWS CloudFront sort of thing can do the work for you, can do the heavy lifting. By this way, all this information or data is available in your CDN. Okay, and your latency is solved there. And with server-side computation, all the renderings are happened in the server side. you just get back the HTML, CSS, that it'll just paint it on the UI. So thereby, the whole of computation is being shifted to server-side computation. And see, dependencies, of course, it's a headache. A lot of times it's a headache. So we have major, let me narrow this down to 4 points, just 4 points, okay? Either share nothing. So if it's a micro front-end, you should not share dependencies at all. Take that stand. And so every MFE will have its own dependency. Of course, it's redundant, but still you'll have to take that stand. The decision is yours. Sharing code, meaning you can just use some runtime modules, or you can use a CDN to pull in your dependencies. One another example I would say is push your dependencies to your private repository or private package, wherein you can use, there is code commit sort of private package where you can push it and get it back later and do it within your own MFE during all this build time. So that is one way. Next is improving performance. So to improve performance, obviously you have to use CDN-based approach for this, and you should use import maps system.js that will help you with module federation and so on. So you take, the modules will take care of the job. And avoid global state management. You don't need the global state. It doesn't need to be cascaded across all the things, right? All MFEs doesn't need your global state. So be wary of that and pick and choose whatever is needed. You don't need to provide everything. So this is how you split your MFE and its dependencies. All right. So here is a small snippet of how you could communicate. So obviously, right, when we have a restriction over global state management and so on, the only way you can do is eventually you can best use the post messages, browser post messages, event passings. So while you pass an event, that will be easy. You just emit an event and catch it from the other component wherever it is needed. It's highly secure. So in terms of routing, you can enable it with single SPA, which is, of course, the default way of front-end these days. This Webpack module federation is an interesting thing. I can quickly show you an example right after a couple of slides. I'll show you a demo of how this Webpack configuration can enable you to create a micro front-end. Thereby, it lets your component to be consumable. And the next thing is client-side composition. So one good example I would say is, how many of you have heard about iframes? How many of you feel cringe about it? Right? So, but we can't just shy away with that, because a lot of times, a lot of legacy applications are still running with that. And there are some technology lock-ins wherein you can't really pick and choose that I don't use iframe at all, because when it comes to payment-related gateway, payment-related things, iframe does the job. And we can't really shy away from that, like how you shrug off for a jQuery. It doesn't the case. Still, a lot of businesses use jQuery. And with iframes, the only way you can communicate is with post message. Okay, that creates an absolute abstraction of things, and it maintains a shell. And you can have some XSR. You can write your own security protocols that will inhibit, other websites to parent that iframe. So there are a lot of ways with which you can use iframe. And there are server-side composition wherein your whole component is rendered as a tag, as an element, right? As a web component. So there are, heard of web components? Yep. So there are web components you can write it with stencils, lit. There are web components, you can just write the components and stitch it as a widget in your website. So these are some ways you can route your micro frontends. Now comes the interesting part. I hope you like it, just because it's about styling. Okay. So with micro frontends, there are 4 ways, right? Like how I said earlier, there is no special treatment. So if you plug in an MFE, all your MFEs will inhibit the parent. So whatever the parent is having, whatever styles it has, it will inhibit the same. It will come across. You will see the same design pattern everywhere. And there is another thing called Shadow DOM. Shadow DOM is something you will find often with stencils kind of library with web components. So Shadow DOM is basically a shell. You write a component. All the styles that you do for a particular component will, anything that happens in Vegas stays in Vegas, right? That's how it is to make it simple. So no matter whatever styles, the same names you use, it doesn't affect the other MFE. The third thing is about naming conventions. It's a hell. Don't do that. Okay, it depends on how your application is. You can't go and manually name your CSS and use it across. You can't trust any Tom, Dick, and Harry to follow the same. That will not happen. So it often, I'll go with CSS modules, which will dynamically, on the compile time and runtime, it will create the names, dynamic names that will help to maintain the CSS. So these are some styling strategies that you have to concern about when designing an MFE. Okay, this is a small example I wanted to give you, wherein how to use a shadow DOM so that it remains confined in the shell. All right. So unit testing, how many of you do that? Right? And whatnot, our AI will help us a lot, right? These days, I bet more than development, it's helpful for us for unit testing. I use it a lot for unit testing. So please do that, at least for the sake of audits. Okay. So unit testing individual apps will be, it'll be easier, right? Once your module is maintained by your individual teams, they know what to write and what to test and what doesn't work. So that in that way, it really helps with integration, end-to-end testing and everything. And so this is a sample Kubernetes file I've given you. So how to deploy a micro-frontend. So with which you could see, right? You can create your own pipeline for the MFE. You can create your own deployments, and you can go with blue-green deployment. This is a good thing. You heard of blue-green deployments? Yeah. So the thing with monolithic frontend, I'm not against monolithic frontend. I'm just saying as an example. You either go or die. That's how it is, right? And your client will not be happy with. Yeah, I got 5 minutes. Your client will not be happy with a blank screen, right? So this is where you can test with blue-green deployments. If your thing really works or not, you can quickly roll back. Somebody talked about rolling back. I believe it was whom? Sorry, I forgot. So yeah, WebView, right? So that's how it is. So it provides all the convenience. So I'm kind of wrapping up every technology in here. So the implementation approaches could be using a module federation, web components, iframes, which we talked about, CSR and SSR. Okay. So I'm not going to go through the list of it. You can probably take a snap, or I can show you later, right? Let me quickly switch to the code to to show you how it really works. Right. Okay, there is an interesting article by, I'll leave the QR for you to code. It's by Joe Mosseri. I don't know, God forbid if I have pronounced in a wrong way. Okay, so he has different ways of doing a micro-frontend wherein you can create a React app as a host, as a remote, and so on. So I've just mimicked this same code and I've tried to spin it up with some by making fewer modifications. Is it visible? Right. So I quickly set up a base app which is running on React, which is a shell app that I've used, and there is a Krakow config. As because it's a create React app, I've used Krakow config to modify it, in which you could see that I have got 3 remote entry points, if it's visible for you, right? There are 3 remote entry points. One is pointing to Angular remote, React remote, and Vue remote, okay? And I have separate projects in here. So for there is a React host, Angular remote, React host, React remote, Vue, and so on. So I've got every sample in Angular, Vue, and React. And if you could see in the config of a React remote, I'm just pointing it to a source component, which will become a remote entry for me. And in the same, we could see in Vue remote as well, right? I pick a specific source main component that becomes a remote entry for me. So it's all just about making an entry, a remote entry that will make your app instantly as a remotely available component that you can plug into any of your thing. So if you could just render it, what happens is you get this, right? Looks like Harry Potter magic, right? So onto your right, if you could see. So I have a React host app, Angular remote app, React remote app, all coming in as a remote entry, right? So this becomes so easy that it's easy for you to modify, you want to unplug something that your boss really doesn't like or the user doesn't like, it's easy for you to unplug it. Finally, I'm here to wrap up with a couple of slides. All right. So these are some best practices. I know what you do. I'll vouch for. I want to make some companies vouch for it, but I didn't get the testimonies. Anyways, these are some of the companies who are using Micro-frontend. Probably if some of you are working there, you can get a testimonial. So they are more prominently using this. Okay, this is an interesting thing. I want to close with this. When to use a Micro-frontend and when not to use a Micro-frontend. If you are a solo developer who's doing everything solo, don't use it, right? You go monolith. It's all the way you go monolith because it's not your cup of tea, I will say. If you have a lot of cash to spend on computing, go for it. If you have a lot of cash to spend on enterprise, if your enterprise is offering things, go on it. But on other ways, I would say that it's often better to build first, then refactor it. Don't refactor and make yourself complicated. So build the engines, and whatever you feel it as, it's kind of draining, and it often needs more of manipulation, changes. You want to bring in a lot of changes. Then go for Micro-frontend based approach. Depends on what we discussed on the key considerations, on what are all the list of requirements and so on. Thank you so much, and